Subscribe to our YouTube channel, Joy Learning TV.
Hello. It has always been a joy on Joy Learning channel. I am Wisdom Agwesinyala, as you always know, and with the one I'll respond properly. And you can see that I am in my lab coat. It means that everything we're going to do is about practical chemistry. Today, we want to look at volumetric analysis or quantitative analysis by titration. So whenever we talk about quantitative, what are we talking about? We are quantifying. It means there is some calculations that we'll have to be doing. But before then, we want to introduce ourselves to the apparatus that we need in this volumetric analysis by titration. So we want to look at it one by one as we assemble all things that we need in this process. The first on our list is the burette. This is the burette. So this is the clip, this is the tip of the burette. Don't forget, this one has a rubber tubing connecting the tip to the main burette. And the burette can reach to a maximum of 50 centimeters cubed. We have others that are made up of cork. So here it has a cork there. But this is very common in our senior high school laboratories. So we want to use this one so that you can get used to it and see how best you can use it when you are running your titration in the lab. The next thing is the burette stand. So it has a clamp and it has this and a base. The base is heavier and broader so that when you place it down, it doesn't topple over, it will stand firm. So because it is the burette stand or the retort stand, I can mount my burette on it like this. Right. When the burette is upside down like that, you enter a lab and it is upside down like this, it means that the burette is not in use. So always after the end of work, you turn it upside down like that and clamp it firmly like that. But anytime you come and it is upright like this, then it means that that burette is in use. Probably somebody is about using it. So my burette stand will hold the burette in place. And the stand tool, as you can see on your screen, comes in various ways. We can have the metal one. We can have the wooden one. As you can see, I like the wooden one a lot. So we'll be using the wooden one. In your school, if you have this one, no problem. If you have this, no problem. But here we are using the wooden one, as you can see. The next one is the funnel. So I have my funnel here. The funnel is to help me fill the burette. So I have it like that so that I can fill it with a solution. Okay. The position of the funnel should always be on top of the burette like this. So always when you see it, it should be there. So if I take it off, After using it, I return it to its position. We are assembling the things that we need, the apparatus that we need to carry out the volumetric analysis. The next on our list, you can see on your screen, is the pipette. And the pipette comes in various ways. But for our purposes, we want to use this one, the one with the bulb. So this is the bulb pipette. It has a bulb, so that is its name. We have the straight one. Whichever one you have in your school, please, you can use. We have, as you can see on the screen, we have the graduated one. That one is straight. If you have that one too, no problem. You will carry out successful volumetric analysis. The next one is the pipette filler on our screen, as you can see. Because the students in our various schools are large, the population is so large, you may not have this one enough to do for all students. So most of the time, so we want to pipette a solution, you have to use your math. But here, we are going to use the pipette filler. Next one on our list is the conical flask. You can see how it is designed in the form of a cone, and it is specially designed for its purpose, so that when we are using it in volumetric analysis, you hold the top of it like this and you swirl whilst you are running the titration. Also, if you are boiling something in it, it will not easily evaporate, so that you lose whatever is in quickly. The next one on our list is the white towel. On your screen, this is the white towel. So the surface is white. This one helps us to identify clearly the endpoint color change in titration. What about if I don't have the white towel in my school? Don't worry, it's so simple. Just get an A4 sheet, get an A4 sheet like that, fold it like this and fold it like that to give you that. And that you can use it anytime you are performing your titration. So you don't have a problem. What about if you don't have a white A4 sheet? You can use a tissue. If you have tissue in your bag, you can just use it, fold it nicely, and that will serve the same purpose. The next thing is our dropping bottle. And the dropping bottle contains an indicator that we use in the volumetric analysis. The indicator is a weak organic acid or base that has distinct color in acidic medium and then another color in a basic medium. Next on our list, as you can see on the screen, is the wash bottle. The wash bottle contains distilled water or deionized water. This one, you use it in rinsing. You want to rinse your burette, you want to rinse your pipette, you want to rinse your conical flask. Whatever you want to rinse, this one helps you. It has a spout that directs the solution directly to where you want it to be. Then you rinse. The next one on our list is the beaker. The one on your screen is a plastic beaker. The one with me here is a glass one. And because you people are good at breaking things when you are in the lab, you may not have the glass beakers. If you have the plastic ones as on your screen, there is no problem for it. This is to prevent high level of damages because it's a glass. Once you are a little careless, it will break. You cause financial loss to your school. So when you have the glass ones in your school, take your time whenever you are using it. Okay? Yes. Right. So that is our assemble. Now this is the way everything should be arranged. Watch carefully. The funnel should be there, the burette there, the white towel here. So anytime you are clamping the burette, make sure it touches the white towel like that. Like that. There should not be any space. The reason is that when, for example, the bell goes, there is break, you guys are rushing out of the lab. So if you have not tightened the burette firmly and then you go, it's just holding firmly. If there is any wind or something, it can easily hit. And this one is ceramic. So if the glass hits it, it can easily shatter. So always you make sure that you fix the burette to touch the towel. There shouldn't be any space there. Good. Then my pipette here will come like that. The pipette should be located between two blocks so that it will not roll and fall. So it should be there. Then I'll have my conical flask like that too, because one will contain the acid, the other will contain the base. So always you have two beakers, whether they are plastics or they are glass, it's enough. Then I'll have my conical flask there. Then I have my wash bottle there. And of course, the indicator will be stationed somewhere because you are not the only one using the indicator. So this is our assembly. This is how everything should be assembled. So that anytime I walk into the lab, I have it like this. At the end of work, please return everything together like this. If you have any solution spill or water spill, please keep your work area clean and dry. So you will want to have a napkin or a rag or a tissue to make sure that your work area is dry and clean. This is how you assemble. Don't go and scatter everything, scatter. No, unacceptable. Okay, so since we are talking about titration, we will want to define what titration is, and we'll look at some terms that we use in titration. So come along, let's go. What is titration? So we want to define a process. You can use that one. If I don't want to use a process, then use procedure. If you don't want to use procedure, then use method. But don't use the three together. Choose one for yourself and then define. So if I want to choose method, I will say method where a solution, and of course standard solution. A standard solution is any solution whose concentration is known. From a burette, we have seen the burette is added to a known volume of a second solution until endpoint is reached or reaction is complete. How do I know? I'm putting an acid and a base together. For example, I put the acid in the burette, then the base in the conical flask. The indicator will change color. That tells us that the reaction between the two solutions, that is the acid and the base, is complete. And then we stop the titration and do all our recordings. So the reaction is complete. This is marked by the first color change of the indicator used. So the moment you are running the titration and you see a first color change, that tells you that the reaction is complete. So you stop. Take your readings on the burette and then repeat the process until you get the values. Let's look at common terms. And these are definitions that you have to know them as they are. The first thing is titrant. Solution of known concentration put in the burette. So any solution that goes into the burette must be a standard solution because you know the concentration. So if I know the concentration of the base, I can decide to put the base into the burette. If I know the concentration of the acid, I can decide to put the acid into the burette. Take note, any of the solution can be placed in the burette. Don't say always an acid, always acid. No, you can also put the base. Now the reason why most of the times the base is not advisable to be put in the burette is that the base, example sodium hydroxide, can react with atmospheric CO2, that is carbon 4 oxide, to form sodium carbonate. This sodium carbonate can serve as a cement to cement the cork, that is if I'm using the cork type of a burette, to cement the cork, the tap, to the main burette. So turning it becomes difficult. Some of the corks, they are made of glass, and then the burette itself is a glass, so it will cement and opening becomes difficult. So if you are using sodium hydroxide in a burette that is made up of a cork, then the cork or the tap is glass, immediately you finish work, you need to rinse inside well. Rinse inside well with a lot of water so that there will not be any traces of the sodium hydroxide to react with the carbon 4 oxide in air to give you the sodium carbonate that seals the cork to the main burette. That is another reason why most of our school labs, we have these ones there. So take note. If you are using a base, wash, rinse with a lot of water, immediately work is over. So anytime I put a solution into the burette, that solution becomes the titrant. The next one is aliquot, a solution of fixed known volume delivered into a conical flask, and of course we use the pipette. The pipette gives us specific volume. The one I have here can deliver 25 cm cubed of volume, so it gives us specific, and the mark is there. So if you take it to that mark, then it is 25 specific volume, and this you deliver the solution into a conical flask. So that is the aliquot or pipetted volume. So if I have a solution in a beaker like that, and then I use the pipette to take a solution into a conical flask, that becomes my aliquot. Then we can have a titrant, solution being titrated or analyzed, or solution put in the conical flask during titration. So the moment I place it into the conical flask like this, it becomes the titrant because I'm going to titrate it against the solution in the burette. If it is not being titrated, then you can say aliquot. The moment I'm going to titrate it with the solution in the burette, it becomes a titrant. Then we have the titer or the titer value. Volumes of titrant reacted in a titration to give the endpoint. So as I said already, I'm running a solution in the burette into another solution in the conical flask, and I see a color change. That is the volume of burette I need to develop the color change in the indicator used, or the difference between two burette readings. So if I have my burette reading, let's say I start from 0.00, then I run the titration and I have a value of 18.00, then I take the difference. So 0 minus 18.00 will give me 18.00, and that gives me the titer value. Or I can say volume of solution from the burette that is needed to reach the end point. That is, so I have 3 definitions there for you to take from. Pick the one you want. Don't go and be learning all of them. Just take the one you are so comfortable with, so that whenever you are asked to define what a titer is or a titer value is, you'll be able to give without thinking too much. Okay. We are still looking at common terms in titration. Then we talk about consistent or concordant titers or concordant titer values. What are these? Any 2 or more titers that do not differ by more than plus or minus 0.20. So it means that if I have 2 values, let's say for example 20.00, and then I have 20.20, these 2 values are consistent. If I have 20.10, 20.15, these are all consistent values or concordant values. However, if I have, say, 20.00, then 21.00, these 2 values are not consistent. Therefore, we can't use it in calculations. Or any 2 or more titer values that differ by a maximum of 0.20. A maximum, it means that I can have 0.00 difference, I can have 0.10 difference, I can have 0.15 difference, and then I can have 0.20 difference. Maximum difference. More than this, say 0.25 or 0.30, your values are not consistent. So these are guiding principles that when you are running your titration, you guard against these things. Then we have the average titer values. So the average of 2 or more consistent titers. As I said earlier, if your values are not consistent, you can't use them in calculation. So you are going to average 2 consistent titers. So if I have 20.00 and then 20.10, these are 2 consistent titers. So I can use them in averaging. So I can say 20.00 plus 20.10 all on 2. Then I have my evaluated average. That value will be used in my calculations. We can also talk about the equivalence point. A point in titration when the amount of titrant added is the stoichiometric amount needed to react with the amount of the titrant. That is the equivalent point. Take note that the equivalent point is different from the end point. So the end point in titration That is the point at which the indicator just changes color. So the indicator just changes color. That is the first color you see in the process of titration. It is different from. So the equivalent point gives us more accurate work than the end point. Because the end point is not marked by necessarily a neutral point. You add an acid to the base, then you see indicator changing color. Then you say, oh, the resulting mixture is neutral. No. The color change of the indicator is either slightly acidic or slightly basic. So it's not always neutral. But in equivalence point, if we are talking about equivalent point, it means that the amount of the acid is equal to the amount of the base. So this one will give us more accurate values than the end point. But in our level here, we are just practicing to obtain the necessary skills. So we use the indicator to just indicate that the reaction between an acid and a base in acid-base titration is complete. So the indicator changes color and then you stop the titration and read your values. The indicator. A weak organic acid or base that has one color in acidic medium and another color in basic medium. So if that is the case, then it reinforces the fact that the color changes will be slightly basic or slightly acidic to see a color change. Otherwise, the color will not change. On the other hand, the chemistry of indicators is just an addition of a proton, H+, or removal of H+, and that brings about the color change. So if H+ is added to the indicator, it has a different color. If it is removed, it also has a different color. That is why they are needed in acid-base titration. Since we are performing an experiment, then we should also be aware of some sources of errors in the volumetric process or the titration process. Number one on our list is incorrect reading on the burette. The burette is read in 2 decimal places for high accuracy. So I will have, for example, 20.00 or 20.10 for high accuracy. Now somebody will read the value and say 20.15. How did you get the 20.15? How did you read the 0.15? You see, so if care is not taken, you might commit an error there. And take note that a meniscus is formed in the burette. So it forms a curved surface. This is a colorless solution. So if you want to read, you must read at the bottom of the meniscus, where the curve is just touching a calibration on the burette. If you read on top, that will be an error. So it means that if you are not able to read it, maybe instead of you reading from the down part, of the curve, you read on top of the curve, that can also affect the accuracy of your work. Number 2, spillage or some of the solution mixture in the conical flask. So in the conical flask, the way it is designed, you hold the top there whilst you swirl in the process. If you hold here, your hands may not be flexible enough to swirl. So you hold here, you are shaking before you realize some of the solution is off the conical flask. That one can also affect your work. So take note, it's a gentle swirling like that. Addition of too much or too little indicator can also affect our process. So here we will talk about 3 drops of the indicator in the process. So whenever I pipette my solution into the conical flask, I use 3 indicators. Or sometimes you'll be asked to use 2 drops of the indicator, and that will be fine. Dirty burette or conical flask or pipette. These are volumetric wares that we use, and their design is for accuracy. So if you are using them dirty, they can interfere with your process. There could be contamination of the burette or the pipette or the conical flask or the beaker that is even containing the solutions. If that is the case, a reaction can occur that can cause the solution to either increase in concentration or decrease in concentration, and that will also affect your titration process. So always the burette, the conical flask, the pipette must always, and of course the beakers must always be clean. They must be clean. At this stage, you don't do much of the work. The lab technicians or your instructors will clean everything for you. So when you come into the lab, you only rinse inside. And also rinsing inside is a way of taking out any contaminant or removing any contaminant from the apparatus that you need for the process. So it's very, very important. Anytime you want to use them, make sure everything is rinsed before you use them. The next one, exposing the stock solution of the base to air. If you prepare the solution, the most sensitive one is sodium hydroxide. Because sodium hydroxide can absorb CO2 from the air. So if you prepare sodium hydroxide solution and you leave it in the open, it can absorb CO2. And this absorption can affect the original concentration, and that will have its effect on accuracy. You are using the burette and it is leaking. So it means that you take an initial reading. By the time you go to pipette and add indicator and start, it's leaking. So you have lost. Now you have written down the initial reading already. But where you are starting from is not it. So that will affect your final reading and it will affect the whole thing. When the solution undergoes a dilution, it can also affect your process. This is very, very important. The endpoint incorrectly approached. What did we say? We said that the endpoint is marked by the indicator just changing color. It means that just changing color, it can lead to some other color. So the just one is the first one, and that is the accurate. After that, you have overshot the endpoint, or you have passed the endpoint. Therefore, the values you are going to read will not be accurate. So take note of these things. shaking of the content of conical flask instead of swelling the flask during titration. So you swirl like that, then you will be shaking like that. Yeah, shaking. So it can affect when some of the solution jumps out, so to say, out of the conical flask. It means that the volume you pipetted earlier will be less, and that will also affect the endpoint value. The next thing, so if those errors can appear, then how do we prevent them? Let's look at precautions in titration. Number 1, rinse burette or pipette with solution before use. So if, for example, I'm going to use the acid in the burette, I have to rinse inside the burette with the acid after rinsing with distilled water. You are conditioning the burette. You are removing any contaminant in the burette. So that process is very, very necessary for accuracy. Ensure that a burette does not leak. So if your burette is leaking, you take a value, you turn yourself, you come back, it's leaking, so you have lost some solution. That initial reading you have made is affected. Wash or rinse conical flask with distilled water only. So, with distilled water only. If, for example, I'm going to use the base inside the conical flask, and I use small of the base to wash inside the conical flask, to condition inside the conical flask, you cannot let go all of the base from the conical flask. So it means that if I go to pipette 25 cm cube of the base into the conical flask, the volume will increase. And that will also affect the endpoint color change and will affect your titer value. So only distilled water to rinse inside the conical flask. Avoid trapping air bubbles when filling the burette or pipette, especially if you are using this type of burette. The rubber tubings here can hold a lot of air inside. So if that is the case, you have to, when you are filling the burette, to a point, open and make sure that every air bubble in here is removed. You can decide to massage the rubber tubing to let go of air bubbles. Make sure that the rubber tubing is really containing nothing but the solution in the burette. No volume should be lost during transfer of solution. So that transfer of solution, you are using the pipette. You need to take it from one point to the other. So from the beaker into the conical flask. You are going to use your index finger to seal the top of the pipette. So if you don't seal it well, in the process of the transfer, some could be lost. And when that happens, it will also affect the titer value. If your finger is dry, you may not be able to seal it properly. So you wet your finger with water so that it will be able to seal it well. Remove funnel after filling the burette. So this is my funnel, and I'm filling the burette like that. After filling, you see, when you shake it, you see that there are some drops of solution coming out. So you do that, you remove before you take any reading. If you don't do it like that, and you take your reading, those solutions that have clinged to the funnel may drop in the course of work, and that will affect the volume. So always remove the funnel before you take your reading and then run your titration. Burette should stand upright before taking a reading. So it should be upright. If it is like this, you are reading, it may affect. That's why we said that incorrect approach to reading the burette will affect your readings. That is the source of error. So always you make sure that the burette is upright before you take your reading. Burette reading should be done at the bottom of the meniscus for colored solutions. So it forms a curve. So you read at the bottom of the curve, where the bottom just touches a calibration on the burette. That is where you take the reading. But for colored solutions, the curve, the down part of it is so dark that you may not be able to see any reading to read. Because of that, you read on top of the meniscus. That is clearer enough for you to take the reading. So for colored solutions, you read on top of the curve, that is the meniscus. For colorless solutions, you read at the bottom of the meniscus because it is clear for you to see the calibration. Raise the drop off the tip of the burette into the flask after ending. After end point is reached. So when you run the titration, there is a last drop there. There is a last drop there. That drop must be taken off into the flask. You see, you must make sure that that drop has gone into the solution mixture in the conical flask. How or in what ways do we apply titration? Or what are the applications for titration? Number one, we can do titration to calculate the concentrations of an unknown substance solution. We can also do that for percentage purity or impurity of salts, percentage composition of a mixture of two bases. We can use it to determine molar mass. We can use it to determine the water crystallization of hydrated salt. Solubility, we can run titration to calculate solubility. Mole ratios, basicity of an acid, we can do titration to find all these things. The last thing in our segment will be the parameters. What are the things we have to focus on as we run titration? Number one, amount of substance in a given volume. A question can ask us to do that. Concentration in mole per dm cube or in grams per dm cube. The question can ask us to do that. Percentage purity and impurity solubility in moles per dm and in grams per dm. The questions can ask us to do that. Relative atomic mass, we can use titration to determine relative atomic mass of an unknown substance. Volume of gas produced or dissolved, we can use titration to do that. Percentage composition of a substance, titration, we can use it to do that, or question can ask us to do that. And of course, these are the things we will be looking at in the course of these lessons. Mass when volume is evaporated, or volume when mass is given. We will also look at that aspect. Then determination of water crystallization, we'll have to also address that. Number of ions or molecules or atoms in solution, we will also address that one. Right, so these are some of the parameters at this stage we'll be looking at in the course of the lessons on joy learning. And always with me, Wisdom Agbesinyale, as with the one. Let's all enjoy chemistry on joy learning. Bye-bye.
Subscribe to our YouTube channel, Joy Learning TV.